Observing that's been going on really since the 2nd century BC with the ancient Chinese records.
The grand astronomers of the Chinese imperial court observed the sun with their naked eyes each dusk and dawn. The first to record sunspots, they noted crows, pears, and goose eggs on the face of the sun. These apparitions foretold the death of emperors and other calamities. It was not until Galileo aimed his telescope at the sun that sunspots became an object of scientific study. Galileo confirmed that these blemishes lay on the surface of the sun, where they waxed and waned and were carried around by the sun's rotation. His claims shocked the world. He had suggested that the sun was less than perfect.
And we do these drawings in the exact same way in many respects as Galileo did in 1610. So we're carrying on that tradition, but we're adding to the scientific data over all these centuries involving the activity cycle of the sun. Now, sunspots can appear as anything from a single speck on the sun to a large, well-developed area like you see here. In fact, it can be several times the diameter of the Earth. If I put this BB that represents the Earth over that sunspot, you can see the size relationship there.
The sun so dominates our planet in size and power that even the smallest change might be felt on Earth.
The sun's output certainly will affect the Earth. A change of just 1% on the sun, extended change, could change the Earth dramatically in a way that maybe the Earth's climate could not recover from.
The sun is suspected to have shaken our climate in the past. A long cold spell began in the 1600s. Ice skaters raced on Dutch canals that had never been frozen and haven't been since. From 1645 to 1715, astronomers happened to note an absence of sunspots over the course of 6 solar cycles. Was this solar anomaly somehow the cause of a miniature ice age? Today, we know that the sun's brightness varies over its 11-year sunspot cycle. When spots are at a minimum, the sun is dimmer by 1 part in 1,000. At solar max, a brighter sun seems likely to warm our planet. Yet Earth's reaction is so complex, we still don't fully understand it. Ironically, some hope to find the answer written in ice. A Himalayan expedition set out in 1997, and during temperatures of 15 below Fahrenheit, 45 people made the trek. Documenting their climb with a video notebook, they lugged 6 tons of equipment, even a refrigerator, to a glacier called Dasupu.
Yes.
There they drilled an ice core at a record-breaking elevation. For one man, this core just might hold the answer to how the sun can influence our climate.
If you go and you succeed in recovering an ice core from the top of the Himalayas, 23,500 feet, in an area where no ice core has ever been recovered, you can be assured that you're going to find something new and exciting about how the Earth's climate works.
For expedition leader and glaciologist Lonnie Thompson, the greatest challenge was transporting these delicate cores, unmelted and unbroken, to a deep freeze in Ohio. Here at the Byrd Polar Research Center, 6,000 cores are kept at a constant -40 degrees. The oldest record dates back over 500,000 years. Earth's weather inscribes a detailed history in ice. Precipitation is recorded, as are volcanic eruptions and temperature swings. Thomson has to tease out which clues speak to the sun's impact on Earth's climate.
We're looking at a meter of ice core that comes from Sajama in Bolivia. This is from about 22,000 feet. The ice core represents a period of time of about 400 years ago. As you go down the core, you can see variations in light and dark ice, and these represent going from the wet season, where you have the clear areas, to the dry season, where we have the dust layers. And we can put these together with the analysis in the lab and come up with a history of both the climate and the environment in this period of time for a part of the world where we have no records. So it's a frozen archive of our past.
By piecing together information from his global collection of cores, Thomson is seeking evidence of a historical pattern. A clear connection between the sun's cycles and the Earth's climate. In a laboratory far cleaner than an operating room, every inch of ice is studied. Pollen, ash, dust, even trapped bubbles of gas are all valuable clues to reconstructing our climate's past. The most intriguing find lies in the chemistry of the ice. After the cores are melted and tested, Thomson is able to chart a record of Earth's temperature. Results show a clear 11-year cycle in Earth's climate, a pattern in sync with the sunspot cycle. As it dims and brightens, our rhythmic sun seems to be leaving its mark on our globe. But a record from just one place on Earth isn't enough to prove a global pattern. So Thomson sets out on another journey, stumbling upon a site unlike any he had come across before. The first Westerner to trek this remote ice cap in Tibet, he discovered an unusual record of the sun's 11-year cycle, etched in visible terraces of snow. Here, even the subtlest shift in our sun has made a clear imprint on Earth.
If you stop the video, you can count those layers between those bands. Each of those layers is an annual dry season, spring, when the sand is moving on those sand dunes, you get the annual dust layer. And then every 11, 12 of those, you get the big darker bands that you see on the cliff that are associated with activity on the sun.
No one had expected to see such a clear signature of the sun's cycle on our planet. One of the oldest ice core records discovered, the Tibetan terraces could yield a 500,000-year history of our sun. The deeper Thomson looks back in time, the more he'll learn about the sun's changeable nature.
Well, the sun is the most important thing that we have determining the Earth's climate. It was in the early days assumed that the sun was constant, but over the last 20 years we know that it's not constant. There is a variation in the energy output of the sun, and so we need to understand how the sun has varied in the past, because that's part of understanding how the climate on the Earth works.
As he continues to unlock secrets in ice, Thomson is beginning to piece together what the sun holds in store for us. Given how little we know, it is wise to keep an eye on our sun, since for better or worse, we are tied to its cycles. And however much the sun has changed or will change, most life on Earth is bound to follow. Each morning, the sun rises to awaken the world, driving our planet, setting life into motion. In this uncertain universe, the one thing we can count on is that the sun will come up again. But can we be sure that it will be the same? We are just beginning to discover the dark side of the sun.